Hi guys, welcome to Code with Navneet. So today we have a topic called scaling. Basically, there is a two type of scaling, horizontal and vertical scaling. So we will learn how to use horizontal scaling, where to use the horizontal scaling, and where to use the vertical scaling. So first thing will come into our mind is what is scaling. So scaling is nothing but a process of growing or shrinking of a system. Like suppose you have a system which is growing and you have a system which is shrinking. So you have to handle a data according to that, right? So that is called scaling. Now when I say growing of system means, now like take example of Google. Some 10 or 15 years back there is a certain data which handled by the Google, right? So very few people are accessing the internet, or maybe less number of people are have access to the internet. They are searching, so the amount of data they are handling is less. But over the period of time, that is got increased now, right? So now Google is handling lots of data. Lots of people are using internets and the data, and they are storing their. They have a Gmail accounts, so they're storing their data as well, like Google Docs and videos and photos. So all those things are there, right? So for that, they have to have some kind of mechanism to handle those kind of data, right? So scaling is nothing but concept. To use of those concepts, we can handle our data very efficiently. So that is called scaling. Now when we talk about that is called scaling, right? Sorry. Now, what kind of scaling is this? So when we talk, okay, there is a two type of scaling, right? So this scaling is two types. One is horizontal scaling, and another was is vertical scaling. Vertical scaling. So first we talk about vertical scale. So first one, what we talk about is vertical scaling. Vertical scaling. What exactly we are thinking when we talk about vertical? So this is axis. This is a x and y. So this is nothing but a horizontal, and this is nothing but a vertical. Okay, vertical. So when we talk about vertical scaling, what exactly we are trying? So like suppose you have a system, some kind of system, right, which has a hard disk of like 1 terabyte hard disk or 16 GB RAM. If you want to increase that, if you want to use the vertical scaling concept in this point, what you exactly need? Just increase the capacity of this single system. So I would say like 1 petabyte kind of data I will store. I have this HDD. So I increase that, and my RAM I increase to suppose 64 GB, or maybe more than that. I don't know what is the capacity of, what is the most like what is the highest capacity available for RAM. I don't know, but just take an example of 64 GB. So in this case, what exactly we are doing? We are vertically increase the capacity of this particular system. Okay, so that is called vertical scaling. So in this case, what we have learned it, when you increase the capacity of one particular system, right? So those kind of things is nothing but called as a vertical scaling. Now we take an example of horizontal scaling. Horizontal scaling. Now suppose you have one system which has a 1 TB HDD and 16 GB of this thing, RAM. Now what you do, you want horizontally scale. Then you no need to worry about this particular system. You should not like no need to scale this. What you will do is you will connect one another system with the same kind of configuration in the network, and then you need more, you can connect more, then you need more, you can connect more. So it means what you are doing is you are not actually increasing the capacity of that particular system. You are connecting a same kind of capacity of network, more systems with the same network. So in this way, what we are doing is basically we are increasing our uh, systems. So in our network, our system capacities automatically got increased, but in the way of horizontal scaling. So we are actually, what we have done is we are not increase the capacity of one system, we are increase the number of systems. So that way also we can handle large data. So basically, why when scaling is needed is basically to handle the large amount of data, not for the small data, but large amount of data. So this is the basically definition of this. Now we can say, now we will learn about the difference. What is the difference between these two guys? Okay. So this is vertical scaling and horizontal scaling. So when I talk about horizontal scaling, as you see in horizontal scaling, we have multiples system. So when you have multiple system, as we discussed in our intro, right, we have to balance the load of all systems because the capacity is not much. So anyway, if I increase the capacity, I have that limitation, right? At certain amount of time, there is a limitation for the hard disk, or there is a limitation of the hardware, right? You cannot proceed more than that. So you have to connect to some other system as well. So that time you have to balance the load. So load balancer is needed. Load balancer needed. Okay, in this case, but in case of vertical scaling, you don't even need, because only one system, right? So not required. So not required. Okay, load balancer is not required. Now next, when I come to the second point, what will happen when the second point is there? We have lots of systems connected to each other. It is very difficult that whole of the system get shut down, right? If you have multiple system, you connected to the different power supplies, different phases, it may possible that one of the phase is down, so one of the system will go down, but not all of the systems will go down, right? So the system failure is less, so we can say it is resilient to system failure. We can say it is resilient to system failure. But in this case, this is definitely a single point of failure, right? So this is a, because we have only one thing. If this will go down, so it's down. Also single point of failure. Single point of failure. Now, what will be the third point? What you can think of now? What will be the third point? If I have a multiple systems in connected, right? What will be there? So things come into the mind is, which is third point, data inconsistency. When do you need, like you don't know where your data is going and where it is going to store, so you have to have some technique to use to store the same kind of data to the same places, right? Or same user id will store in the same place. So those kind of things, anyway we'll learn it. So but data may be inconsistent, right? So data and inconsistent data inconsistency. So basically data inconsistency will be there. Okay, here it won't be there because only one thing, right? So here data is consistent. So here consistency will be there with data. Now fourth point, which is almost the last point for us, is like when you have the horizontally scaling kind of thing, you can create multiple of systems, right? So you can create n number of systems. Maybe n is a limited. We cannot create some crores of or billions of system to each another, but we can connect some of the systems, right? So it means that it is scalable. So we can scale well. Okay, but when it comes to here, it is just one system. So there is a capacity of limitations of this thing, limitation of hardware, right? Limitation of hardware. So we cannot scale much. So there is a limitation of scaling, right? So here, limitation of scaling. We cannot scale much. So this is one kind of thing which we struggle with scaling. So yeah, This is basically a vertical scaling and horizontal scaling. So now you understand, right, what is exactly horizontal scaling and vertical scaling. It's not too hard to understand. It's very easy if you connect multiple of systems, or maybe the high capacity system, multiple systems you connect to the same network, then it becomes a horizontal scaling. And why I'm talking more about the networks, because they have to communicate to each other, and it will happen in the distributed system and the network connectivity, right? So that is required. But when I talk about vertical scaling, it's just one system, which is a high capacity system, which has a very large amount of capacity to store the data, right? That is only one system. It means that it is a single point of failure. It may possible you are running a monolithic application there, or it may possible you can running a like microservices, but the problem is coming to the picture is it's only one single system. You will definitely get a single point of failure anytime. The chances is high. So yes, that's it. That's what from this video. We will discuss the next component in the next videos. Thank you very much. Bye.